Hello, in today's video we're going to be talking about the law of multiple proportions. Now this is a tricky law. It has very specific purposes in chemistry, and a lot of students get this confused with the law of constant composition. We will be using the mass percent that we learned from the law of constant composition in the law of multiple proportions, but it's not the same thing. So what is the understanding of the law of multiple proportions? It states that for a given element, that element can react multiple different ways to a secondary element. So let's say we have carbon and oxygen. I know we really haven't talked too much about these elements. We haven't really talked about any of the elements, but carbon is going to have an atomic symbol of C, oxygen is going to have an atomic symbol of O. These are two different elements that are found on the periodic table. Now, carbon and oxygen can form many different ways. A very specific way that these form is very poisonous to humans. The second way it can form, another very common way, is also poisonous to humans, but not as poisonous as the first way. So let's deal with the first one. We're going to say compound, CMPD. That's my abbreviation for compound. A lot of people use that. Compound 1 is going to be made up of 47.9% carbon, and the oxygen is going to be, that's 42.9% carbon, and the oxygen is going to be 57.1%. For the first compound that carbon and oxygen can form, the second compound, the percent of carbon is going to drop way down to 27.3% carbon, and the oxygen is going to be 72.7%. From this alone, you can see that the carbon and oxygen are bonding a different way. There are multiple oxygens formed bonding to this carbon. There are a different number of oxygens bonding to this carbon. So what's this law of multiple proportions tells us? Well, that's actually what it tells us. It tells us that carbon is allowed to bond multiple different ways to the same element. So here, let's figure out how it is bonded. Now, the genius behind the law of multiple proportions, a very famous scientist came up with it, is if you take the ratio of the mass percents of each of the elements of one compound and divide by the ratio of the mass percents of the second compound, it'll tell you a whole number ratio of the number of oxygens from this compound to the oxygens of this compound. That seems very confusing, and I know, but let's see how this works. So if we take the compound 2, let's take the first one, and divide by the compound 1, the mass ratios. Let's take the 72.7% oxygen divided by the 27.3% carbon. That's from compound 2. And let's divide that ratio by the ratio of oxygen to carbon here, 57.1% oxygen for every 42.9% carbon. The beauty behind this ratio and this law, if you plug this into a calculator, will end up giving you a 2-to-1 ratio. It'll be whole numbers. The law of multiple proportions states and specifically shows that you will always get a whole number ratio here. Now, what does that whole number ratio mean? In this case, it's going to tell us that for compound 2, there are twice as many oxygens as there are in compound 1. The carbon is bonding differently to the oxygens in compound 2 than it is in compound 1. And we know that compound 2 has twice as many oxygens as compound 1. Now I'm going to show you what these compounds are. Compound 2 is actually carbon dioxide. There are 2 oxygens and 1 carbon. We know that this is a 2-to-1 ratio now between compound 1 and compound 2, so we can easily identify what the molecule is for compound 1. There has to be half as many oxygens, so it's going to be carbon monoxide. This was a very huge experiment that went on back in the day in chemistry, and it showed that these will always give you whole number ratios. A lot of science comes out of people lonely at night, bored out of their minds, throwing numbers together, trying to divide numbers, find ratios, find these results that kind of connect each other. And this law kind of came out of that. You can see that this has twice as many oxygens as this one. The ratio of compound 2 to compound 1 is twice as many to a single. That's a huge result, and that's what the law of multiple proportion states. We're not going to deal with it very often. However, it does come up in these weird, peculiar ways throughout the semester, and I'll let you know when it does. With that, that's all I want to say in this video.